This semester, our team worked to find a means of providing customers with insightful information about how factors like education, family size, gender, race, and many others can affect their medical reality. Using machine learning, we worked to create a way to point customers in a better direction for future hospital and insurance expenses. The hospital expenditure data that we used was sourced from the MEP survey data conducted by the Agency of Healthcare Research and Quality. In this survey, respondents provided information such as race, college level, income, familial size, and marital status. Additionally, we also investigated information on insurance costs to customers through a dataset we found in a GitHub repository owned by Zach Stegnick. In the previous stage of our project, we began experimenting with linear regression models in order to locate patterns between features of physical, educational, financial, and familial attributes of the MEP survey data. For this stage, we used the data from our last research to build various models to test these relationships. We then evaluated these models to see which could best predict future trends in hospital expenditures and insurance costs.
In the final stage of our project, we started testing our two data sets with various regression models. We split the data into 60% for training and 40% for testing. For the insurance data, the features we use to find patterns are age, sex, BMI, children, smoker, and region. We then proceeded to run SVR, linear, polynomial, and ridge regression. For our MEPS data, the features we use to find the patterns are race, gender, marriage status, education level, physical status, and income level. There were many other features in the given dataset, but we decided to go with these features since our previous experiments in the midterm report showed that these features were the most significant of all others. We then proceeded to run the same regression models as the insurance dataset, except for SVR regression, since we found that SVR regression generated a negative R2 score for the insurance dataset.
The result of our insurance data with ridge regression and linear regression is around 0.75 for our regression score. We were able to achieve a higher regression score of around 0.85 when we use linear regression with 2-degree polynomial features, that is, linear combinations of x, x squared, and 1, all that together. And however, with the SVM regression model, we got very poor results, resulting in a negative R-score of roughly negative 0.1. Therefore, we decided not to use this model for our MEPS data because it returns similar results on similar attempts. For the MEPS dataset, however, the results weren't nearly as satisfying for the other tests as they were for the insurance dataset as they were for the MEPS. For the ridge and linear regression, we only got a score of roughly 0.1 for both of them. And the polynomial linear regression, which is the highest score in either dataset model testing, we only got 0.4 for our R-score. To do further tests, we used a test dataset and ran that through our model to see what the score was, and that resulted in a negative R-score of negative 0.01, which meant there was very little correlation and it was very erroneous in terms of the model overall. We were also able to deduce, after looking through our MEPS data, that almost a third of the expenditure output data that we had was 0 in its absolute value, regardless of what the insurance data actually was, making us question the validity of our data set. For the final product of our research, we decided to use our insurance model data set to make an application, which would ask the user for their own information, such as the ones that were used in our insurance dataset: age, sex, BMI, number of children, smoker status, and the region of the US they come from. Once the user clicks Submit on this window, a new window pops up with the expected annual cost of insurance. For our model, we decided to use the scikit-learn linear regression model from the scikit-learn libraries And we decided to use a polynomial transformer on our data, like we did in our previous tests, but to a polynomial degree of 2, as that was our experimentally highest R-squared score, or our regression score of roughly 0.84 for our training and roughly 0.8 for testing. To construct our application visually, we used PySimple-GUI library, which made constructing our layout and our windows much easier.
Ultimately, we were able to achieve a basic prototype of what we'd want for our final goal. The program produces an expected insurance cost based on users' information. We were disappointed to see the poor performance of our MEPS data with our models, as it has much more of a comprehensive list of attributes to look at than our insurance dataset does. If we were to continue this research, our first steps would be to analyze the variables we left out of our experiments and see what kind of effects they had on our model's accuracies. We hope that this research also inspires other researchers in our field of machine learning to come up with ways to build on top of what we've provided.